All right, everyone, next lesson, 8.4, transformations of quadratic functions. So, we've already learned that the graph of every quadratic function is a U-shaped symmetric curve called a parabola. The blank is the minimum or maximum point of the parabola. You should know that is called the vertex. The blank is an imaginary vertical line that divides the parabola in half. You should know that is called the axis of symmetry. We learn how to graph the blank function y equals x squared. That is called the parent function. That's your basic parabola. So if we draw a little picture over here, your basic parabola goes through the origin, has its vertex at the origin and goes upward like that. That's your basic standard parent function parabola. Now, in this lesson, we're going to learn how to graph other parabolas that aren't necessarily stationed at the vertex. We're going to graph parabolas that are maybe a little bit stretchy or flat or wide or narrow, or we're going to see ones that are flipped. We're also going to see ones that are moved around. And these are called transformations. So we're going to learn 3 transformations today. We're going to be doing reflections. A reflection is just a flip. We're going to be doing translations. Translation is just a slide. And the last one's called a dilation, which is a stretch or a compression. Okay? All right, so on the next slide, here's your standard form of a parabola. The A, B, and C values all affect different transformations of the parabola. So if you zoom in a little bit here, the A value, the very first number you see, will affect 2 things. It'll affect the dilation of the parabola and its reflection. The dilation is how much it's either stretched or compressed. Okay, so you may see ones that are real tall and skinny. Those are being vertically stretched. They're narrower. Then you may see other ones that are real wide and flat, like this. Those are called vertical compressions. They're getting flattened. Vertically compressed. They're wider. All depending on that A value. Okay? The A value also controls whether or not the parabola is reflected. So if the A value is positive, it won't be reflected. But if the A value is negative, it will be reflected. Okay? So that's down here. Transformations of quadratic graphs, concepts to remember. If the A is positive, the parabola opens up. But if A is negative, the parabola opens down, which makes it a reflection when it opens down. Okay? And so to tell whether or not the parabola is stretched or compressed, you look at the A value. If the A value is greater than 1, then it will stretch the parabola vertically. Like this picture up here. That's a vertical stretch. Okay? But if the A value is between 0 and 1, aka it's a fraction, then it's going to be vertically compressed. It's wider and flatter. Stretched is taller and narrower. Okay? The B value affects the horizontal translation, and the C value affects the vertical translation. Those numbers will affect where the parabola is moved around on the coordinate axis, horizontally and vertically. And to find the horizontal and vertical translations, all you're doing is finding the vertex. The vertex tells you where the parabola is being moved to. Your parent vertex is 0, 0. That's always your vertex before any changes are made. But then whatever your new vertex is, the X is your horizontal shift and the Y is your vertical shift. Okay? So we will pick up an example in the next video.